All right, this is 7th grade, Module 4, Lesson 13 on changing scales. So on our opening exercise here, we have a little equation or formula that you want to use. So when finding the scale factor, you take the length of the scale drawing and divide it by the corresponding length of the original drawing. So you always want to go back to the original here. So describe using percentages the difference between a reduction and an enlargement. And we talked about this in lesson 12. So this is kind of a repeat question. So we're going to say original. Always is 100%. So whenever you're talking about the original is always going to be 100%, even if it's the smaller image there. Okay. And then we have a reduction. A reduction is between 0 all the way to 99%. That's considered a reduction. And then an enlargement is between 101% to infinity, actually, because it can go on forever. All right, let's try our first problem. Use the two drawings below to complete the chart. Calculate the first row, drawings 1 to 2 only. All right, so you can see we have this side corresponds with this side. And I'm going to change up colors here. This side corresponds with this side. So that's how we're going to set up our numbers on the table right below here. So I'm actually going to erase this and go ahead and drop down to this table. So you always want to look at how they're wording it as well. Okay, this is going from 1 to 2, and then this one's going from 2 to 1. All right, so the quotient of the corresponding horizontal distances. So on the drawing 2, we had 3.92, because that's the scale, and then the original was drawing 1, which was 2.45. When you divide that out, you get 16. Now the vertical distance from drawing 2 was 2.4, and again, that's the change drawing, over the original of 1.5. And when you divide that out, you get 1.6. Okay, actually, this one over here is actually 1.6 as well. I forgot my decimal and I said 16 because I wrote 16. Sorry, 1.6. So what is 1.6 as a percent? So 1.6, remember 2 places to the right, gives me 160%. So that drawing 2 is 160% larger than drawing 1. So what is this? It's an enlargement, and we'll just put an E for that. Now we're going to go in the opposite direction. Now we're going to make drawing 2 the original and drawing 1 the scale drawing. So the horizontal distances this time will be 2.45, and now the original is 3.92. So basically the flip of what we just did up above. And when you divide that out, you get 0.625. All right, so the vertical, again, we're just going to kind of flip this around, making now drawing 2 the original. So putting drawing 2's lengths on the denominator area. We divide that out, we get 0.625. So what is 0.625 as a percent? Well, remember, we go 2 places to the right. So it is 62.5%. Now, 62.5%, you have to ask yourself, is that less than 100% or more than 100%? It's less, which makes this a reduction. All right, it says compare drawing 2 to drawing 1. Using the completed work in the first row, make a conjecture, which basically means a statement, about what the second row of the chart will be. Justify your conjecture without computing the second row. All right, so we're going to say from drawing 1 to, oops, that's an R, drawing 2, it is an enlargement. All right, now compute the second row of the chart and was your conjecture proven? All right, I'm going to move this up real quick. Erase that and move it up just so I can write a little easier here. All right, we're going to say from drawing 2 to drawing 1 is a reduction. So basically, we're just proving our table up above. We're making a statement proving that our math up above is correct. Now we have some hearts here on example 1. All right, so the scale factor of drawing 1 to drawing 2 is 60%. All right, so that makes this the original, and it makes this one the 60. So what we're going to do, since we don't have any lengths on this one because the side lengths are curved, we're going to set this up like an equation. We're going to say 100% equals percent times 60. Now I got to figure out what this percent is, so I need to move that 60. So I'm going to divide by 60 to both sides. And those cancel. And I have a 0 rule here, so I can get rid of some of that. So I can say 10 to 6. And that reduces down to 5 to 3. And so the percent, turning this into a mixed fraction, becomes 1 2/3%. Also, if you did it on a calculator, you would have got 1.66, and it keeps repeating. And as we discussed in class, when you repeat 6s, it's 2/3. All right, let's try the next page. A regular octagon is an 8-sided polygon with side lengths that are all equal. All 3 octagons are scale drawings of each other. Use the chart and the side lengths to compute each scale factor as a percent. How can we check our answers? All right. So on this one, we don't really have an original. It depends on who we're comparing. So I'm going to move this up a little bit. And you guys have your drawings hopefully right there in front of you. So you guys can look back at the side lengths. We're going from 1 to 2, which makes 1 the original. Remember, original goes on the bottom. So drawing 1's length is a 10. Drawing 2's length is a 12. When you divide this out, you get 1.2, which gives me 120%. So I need to write an equation to illustrate this relationship. So I could also say 10 times 1.2 gives me 12. And there's my equation. That's it. All right, let's try the next one. I'm going to go from 1 to 3, which makes 1 the original. So the first one they mention is going to be your original. That's going to be your 100%. The second one they mention is your scale drawing. So the first one they mention, this one goes on bottom. The second one they mention goes on top, if that kind of helps you a little bit. So that's a 10 again underneath. And if you look at drawing 3, the sides are 8. If I reduce that down, I get 0.8. And that as a percentage is 80%. So my equation here would be 10 times 0.8 equals 8. All right, now I'm going to go from 2 to 1. So 1 now is the scaled, and 2 is the original. So 2, we're going to put a 12 down here for the original. We're going to put a 10 up above. I'm going to reduce that to 5/6. All right, and as we know, that might be not a nice decimal percentage. So I'm just going to come over here and calculate my equation and kind of show you what that looks like here. So I'm going to say 12 times 5, 6, which actually works out kind of nice here because my 6 cancels into my 12 2 times, and 2 times 5 is 10. So there we go. But let's look at what that looks like on a calculator anyways. So I'm going to pull up my calculator here. We're going to say 5 divided by 6. Yeah, it's a repeat decimal. So this is going to be 0.8 1/3. I would just leave it 5/6 for right now because when I repeat decimals like that, it's not as easy to turn it into a percentage. So we're just going to leave it at 5/6 for this one. And on the quiz, I'll let you do that as well if they have a repeat decimal, because to teach you how to deal with repeat decimals is a different skill on itself. So we won't go there just yet. You'll get there, but not today. All right, so now we're going from 2 to 3. Remember, 2 is my original, which means it goes on the bottom. So we're going to say 12. And 3 is my scale drawing. I'm going to reduce this down to 2/3. And again, that's another example here. If I say 2 divided by 3, I don't get a very nice decimal, so we're just going to leave it as a fraction. And then my equation here is going to be 12, the original, times 2/3, okay? And if you see, 3 can go into 12 4 times, and then I multiply those. 4 times 2 gives me 8. All right, let's look at 3 to 1. 3 being my original, so it goes down here. 1 has the 10. I can reduce that to 5/4. And again, we can check the calculator on this one. We can say 5 divided by 4. I get 1.25. Okay. So we can say 1.25. That as a percent is 125%. Now to write our equation, I actually see something kind of ahead of time here. I'm multiplying by 8. So if I keep the fraction instead of writing 1.25, I notice I can do something here. My 4 cancels with my 8 2 times, and I get 5 times 2, which gives me 10. So sometimes it's easier just to keep the fraction answer. Last one, we have 3 to 2. So this is going to be 8 and then 12 on top, which reduces to 6/4, which reduces to 3/2. All right, and if we check that on our calculator again, let's see. We have 3 divided by 2, 1.5. All right. So this is 1.5. 2 places to the left would be 150%. All right, I'm going to take 8. And again, I'm actually going to use that fraction one more time because it will cancel out. I can say 2 goes into 8 4 times. Pick a different color there. You can barely see my 4. 4 times. 4 times 3 is 12. So those are your equations, and those are your math examples that go along with those. Go ahead and go to the next page. All right, now I don't offer extra credit very much in class, but this particular problem, if you can tackle this and show your work and show your process here of how you got to your answer, this one is worth 3 points extra credit. Now, if you get it wrong, it does not count against you. If you don't do it, it does not hurt your grade. It's completely extra. So if you want to give it a try, but make sure you show me all your work. So that concludes this video tutorial.